So, thanks for coming. My name is Les Hazelwood. I'm the CTO of Stormpath. I'm feeling a little under the weather today, so I'm doing my best to project. If anybody can't hear anything, please let me know, and I'll repeat what I said, and I'll repeat questions that are asked. Before we get started, just to let you know a little bit about Stormpath. We're a cloud-hosted identity management and access control service. So we really focus on user management. I'm sure everyone here probably heard about what happened to LinkedIn and Yahoo and a lot of these other companies over the last few months. The French National Bank actually had a password problem yesterday. So it's a real significant problem for building cloud services and securing users. We are a cloud SaaS that automates all that stuff for your applications. We provide user security workflows like forgot password, account verification, email verification, locking, unlocking, password reset. And of course, we provide a lot of developer tools and SDKs that wrap our REST API. So if you're interested in this stuff or you're building a cloud-based or internet publicly facing application, definitely give us a try. It's free for everyone to get started. And we solve a lot of the nitty-gritty that apparently a lot of companies are having problems with lately. So today I'm going to cover a couple things. This is sort of a tutorial workshop, and I'm breaking it down into really two parts. The first half I'm really going to spend on REST fundamentals and REST design principles. REST is an architectural style. It's not a specification. And because of that, there's a lot of different interpretations about how REST should work. And so the first half of the presentation is really going to be about design and de facto best practices that we've researched and accumulated and implemented after looking at many, many different REST APIs over the last 18 months. And so this is really a consolidation or condensation of what we consider to be best practices. And then after we cover those best practices and design issues, the last half of the presentation will actually be showing you how to implement those techniques using JAX-RS and specifically with the Jersey framework. It's kind of hard to see, but these are some of the design issues we're going to be talking about. You don't need to worry about them right now. I'll cover them in detail as we go over them. And then again, we'll start focusing on some code in the latter half.
This presentation will be available on
It will be available online. I've uploaded it through the Oracle channels already, and we just had another upload happen just 5 minutes ago, so it should be available shortly. So why REST? There's a lot of people in this room, so why is everyone interested in REST and REST paradigms? Well, Dr. Roy Fielding, the sort of the inventor of the paradigm in his thesis, really quoted 6 reasons why REST is important and should be important in designing scalable architectures. The first one he listed is actually scalability. And by this, I don't mean performance, and the ability to handle hundreds of thousands of requests. Scalability here really means a large interconnected network of machines and or third-party heterogeneous systems being able to communicate with each other, and scale can be reached in size or in quantity because of a common kind of architectural approach. Generality is that because of the way REST is defined and the HTTP verb specifically, it can cover a vast majority of system-to-system interaction use cases. So it's very general in its approach and how it deals with data transfer and data manipulation. Independence, one system can be completely independent of another. Latency is something very fundamental to REST architectures in the form or addressed in the form of caching. And it's something that a lot of people don't talk about with REST, but it's very, very important in understanding the REST paradigm. Caching is critical to how REST scales. Security, because it piggybacks the HTTP specification, there is built-in security techniques to keep REST architecture secure. And finally, encapsulation. A REST architecture or the parts of a system that are exposed over REST architectures can be dramatically different than the underlying or backing systems that they sit on top of. So it allows you to encapsulate more, concrete or even more difficult details behind something that's more general. So you get a lot of flexibility in having this decoupling. So these are the 6 primary reasons, why that Dr. Fielding focuses on his thesis. How many people here have heard or have seen this acronym before? Okay, about half. So HATEOAS is something that's often referred to quite a bit in the context of REST. And these letters stand for Hypermedia as the engine of application state. And that's really a big mouthful, but all it really means, well, most of it, what it means is when a system interacts with another REST-based system, it doesn't need any information beyond the initial request in order to figure out how to continue to interact with that system. So everything that's necessary, from data formats to parsing rules to data types, they're all encapsulated after or based on the first request. And then from there, more information can be found out as necessary, which is really important for auto-discovery or self-discovery of other third-party services. A lot of people view this as a further restriction on the general REST principles and REST architectures, but you'll see a lot of people who are really into REST bring this up quite a bit, because this is one of the cleanest ways to go about implementing REST. It's not the only way. So if you see this, just keep that in mind. So REST is easy, right? Everybody's doing REST. It's a piece of cake, and you've seen a ton of services show up. It's not really the case. Like, it's easy to consume for clients, right? Typically, it's the data payloads are XML or JSON, and those are fairly ubiquitous these days. And clients can interact with that data relatively easily. But for the servers or for providers, it's really freaking hard to get this stuff right. As I said before, REST is an architectural style. It's not a specification. And so there's 6 of one, half dozen of the other ways of accomplishing a lot of things that don't really need to be replicated. So a lot of what we're going to talk about today are techniques and what I consider de facto best practices based on our research. But if you restrict these use cases down to simpler ways of doing things, REST can be easy if you follow some guidelines. And so, again, a lot of what we're going to talk about today is guidelines on how to implement good quality REST services. In the first half of the presentation, I will explain Stormpath's domain. So as an identity and cloud service, we focus a lot on what we identify as applications, directories like LDAP and Active Directory, accounts, which are identities within directories, groups, the associations between these things, and workflows of how these entities are related with each other, how they're changed in workflows. So I think these are things that most people are fairly familiar with. Almost every application to some extent has a concept of a user, maybe groups. And so it's a fairly simple domain that we can all kind of settle on as we talk about these things. So first off, I want to talk about fundamentals. I'm going to bring up the word resource a lot in the context of REST in this presentation. And I want to be very clear here. A resource from the REST perspective is basically a noun. It's a thing. It's not a verb. So things like dog or cat or document or person or user or group, right? These are all nouns. They represent things. And these things can be transferred. Or representations of those things can be transferred, rather. And the more coarse-grained they are, the better. One of the key points in REST architectures is that you don't always know how your clients are going to react to data in the format of your data. So if you keep your data coarse-grained and present a lot of information, your clients can implement and manipulate things and react to things in ways that you could never envision and foresee. So the more coarse-grained, the more data that you represent in a coarse-grained manner, the better it is for longevity of your REST APIs. So changes that happen in the future that you can't foresee today are easily, or more easily handled, rather, if your data is coarse-grained. And this is a good architectural style for use case scalability. So if I want to create a user or delete an application, right, these are CRUD kind of behaviors that are fairly easily mapped to REST. And it's a good basis for that kind of architectural style. We'll also talk about how you can do behaviors too. Yes?
Can you give an example of coarse-grained versus fine-grained?
So, sure. So the question is, can I give an example of coarse-grained versus fine-grained? And so, being a Java conference, a coarse-grained method, a fine-grained method might be, if I have a user service and I want to say user service.set username, and it takes in the user ID and it takes in the username, right? It's very, very fine-grained. It's targeted specifically at that attribute and that attribute only. The problem arises is, what if you want to change their first name or their last name or their postal address or whatever, any of the information about the user? Now all of a sudden you've got to create more methods to support that, as opposed to a single fine-grained or coarse-grained approach, which maybe just takes in a user and it's just a single update method call. Any number of manipulations on that user object can occur, but the backing service still performs the exact same way, regardless of how many or what types of property need to be set. So that's a pretty good example of coarse-grained versus fine-grained. And actually, here's a good example of fine-grained attempts at a REST API. So what if I had, a URL or a URI that says, let me get an account, or maybe I can post and create a directory, or update a group, or verify an account email address. Right? Basically, what this is there's a URI per action that's being defined here. And while this might seem kind of intuitive, depending on the background that you have, the problem is that once your use cases start to expand, you might see stuff like this, where maybe I want to create or search for groups by name, or find groups by directory, or verify account email addresses by token. This can explode very quickly if you try to do the fine-grained approach. And for those that are familiar with older RPC-based approaches, this really starts to smell like an older RPC mechanism. And if you've ever had to support one of those in the past, you know that this doesn't scale well, and you end up having a lot of code to maintain and test and try to fix or take care of for bug fixes. So this really smells like old RPC. Don't do this when you're designing REST APIs. Instead, we really do want to keep it simple. And by that, we go to a coarse-grained approach. So when I say coarse-grained, there's really only fundamentally two different types of resources that you'll ever have to deal with when working with a coarse-grained REST API. The first is a collection resource, which itself contains other resources. And then there is what we call an instance resource, which is a single instance of a particular data type. So an account or a group or a directory that represents one and only one thing. And these are really the only two things that you have to worry about when you're designing REST APIs. And you can represent relationships and stuff themselves as their own entity. We'll talk about relationships in a little while, but initially these are the only two things you really have to worry about. So what do I mean by a collection resource? So in this example, we have a /applications endpoint. And if somebody were to visit this URI, it should return a resource that represented a collection of application instances. Notice here that the URI is plural. It's not singular, so it's not /application. And the reason why is it's a little more intuitive to go to a plural-based endpoint that represents multiple things. So if you keep these in the plural, it's a little more intuitive to consumers of your REST API. They kind of already understand what they're going to get back before they even access the API. But what about a particular instance? So in this example, we are accessing a particular instance of an application below the application's base URI. And so this allows us to further restrict the type of data that we get back within that collection. In this case, we're returning only the application with ID A1, B2, C3. So that's it. There's really only these two types of things that you have to worry about when you're creating your data models or your models for your REST resources. What about behavior, though, right? We've just talked about the nouns, the things that you can interact with. How do I interact with or change data or change state or interact with those resources? And of course, the answer for REST is that REST piggybacks the existing HTTP specification methods for behavior. So there's get, put, post, delete, and head. Right? These are parts of the HTTP standard for the types of methods that can be interacted with an HTTP server. There's also patch, which we won't really talk about today. It's kind of going through an RFC process. It's not fully standardized yet, but these are the ones that people, when they in existing REST APIs today, these are the ones that you'll see most of the time. How many people in this room believe that these represent a one-to-one correspondence with CRUD? Create, read, update, delete. Okay, a decent amount of people. The answer is that can be true, but they're not always a direct one-to-one correspondence. You can model create, read, update, delete based on post, put, get, and delete, but I'll give you some scenarios where it's not a clear one-to-one correlation. Certain methods can be used for multiple behaviors, and it's incredibly important to understand the distinction between these when you're exposing REST API to clients, because these behaviors are sort of defined as de facto standards, and you want to adhere to them to make sure that everybody consumes APIs the same way. There's a lot of violators, by the way, on the web. I won't mention any names, but there's a lot of people that do not adhere to this, and it causes significant problems for people that expect this to be the case. So we'll cover the methods. As you might expect, get, delete, and head are really actually one-to-one correspondence with read and delete. Head just gives back metadata information. It won't actually return a resource representation, but get really does return, it reads a resource, and delete actually does delete a resource. So these are straightforward. What's not so obvious, though, is post and put can both be used for create and update. And we'll talk about how that's possible right now. So you can use put for creating resources if the identifier is already known by the client performing the put. So in this case, we have put/application/client specified ID. In this case, if the client wants to specify their own identifier for an application, they can do that. And the server is expected to use that identifier as the identifier that it saves it in the system. So this is actually a create scenario using put. It's totally legal. But put can also be used for update. This is the thing that people most associate with put. In that when I place data at this, or when I post or put data to this particular URI endpoint, I need to specify a collection of name-value pairs, or whatever that representation is. So, in this example, it's name-value pairs because we're using JSON. But one of the key things to remember, though, is that put, by specification, is idempotent. An idempotent operation is any operation that could be performed one or multiple times and result in the same server state, right? It's incredibly important to recognize here that idempotency as a property for HTTP has nothing to do with the client. A client might execute an operation 5 times. If it fails the 3rd time and not the first 2, it still might be idempotent on the server. And idempotency here is really about the server state, not the client state. But the key point here is that put has to be idempotent, which means you have to send the entire resources representation in its entirety whenever you do a put. It cannot be a partial representation. So in this example, if I'm doing a put for application, this implies that the only 2 properties that an application has is a name and description. And the reason why is that I can't put name on request 1 and then just description on request 2 and expect the server state to be identical after those 2 requests, right? It breaks the rule of idempotency. But if I put the data in, the entire representation in, every single time that I execute that request, I can be assured that the server state will be the same. Really, really important. Put has to be idempotent, has to be the entire representation of the resource. But that's not necessarily true of post. So how can post be used for create and update? So post is typically used for creating things based on a parent resource or a parent collection. So in this case, I am posting an application's representation to the /applications endpoint. And what this is really telling the server is that, hey, I'm sending you data. I want you to create a brand new application instance that's owned or a child to the application's collection resource. And the server can respond with 201 created, and the location header is set to the fully qualified href of that resource that was just created on the server. One of the things that's interesting is because post does not have to be idempotent, you can send in partial representations of objects or resources. So in this case, we're setting the name but not the description. And that's completely legal because post is sort of the one-off in the HTTP specification for methods. Post really means a server directive or server processing directive, and that the server can do whatever the heck it wants to during a post. There's no architectural limitation on what happens during a post. So you have the freedom to put in full or partial representations as you see fit. It also has implications for caching because it's not idempotent, it's not cacheable by proxy servers or caching servers. We'll talk about that performance implications with caching a little bit later. But so you can send partial representations, and probably one of the most important parts of the slide is that you don't want to send back a 200 okay after this executions. You want to send back a 201, and you definitely need to set the location header to indicate to the client, not only have I created the resource, But here is its fully qualified unique identifier that allows you to get access to it later if you want to. So always set your location headers. And in fact, we'll see later on when Jersey, in the Jersey framework, when you create responses in Jersey, it takes in the location as one of its main arguments when it creates a response, knowing that you've created an entity. So this is a best practice. Definitely stick to it. It's really important for portability across APIs. So that was great. Let's talk about post as an update. So in this case, we're sending data to the server via post, and we're sending it to that resource's specific URI endpoint. And here we are sending a partial representation. And again, we're allowed to do that because post does not have to be idempotent. So this could be beneficial depending on your API and how you offer it to your clients. Maybe the data is significantly large, or maybe it's complex, and you only want to, or you want to provide a feature for your customers where they only need to specify the data that they feel has changed. If you have bandwidth limits on services, for example, this can be very beneficial because if your resources are potentially large, the client only needs to send over a small amount of data to indicate what has changed, as opposed to sending over the entire resource representation, which might eat against their bandwidth quota. So this can be very nice to support depending on your use cases for your customers. Yes?
You said about the post as create, and you said you want to always set the location header.
Yes.
What is the advantages of setting a location?
So the question is when you set post as create, or use post as create, and you set a location header, what's the advantage of the location header? The real advantage is that there's not really a notion of an ID in the REST world or in the HTTP world. An ID like A1, B1, or A1, B2, C3, that's really specific to the implementation of my service. IDs in the REST or the web world are really URLs, right? If I want to link from one page to another in a website, or if I want to link from one resource to another, the URL or the URI is the unit of measure by which you interact with and link information. And so by sending this information back, you're saying, hey, this is the fully qualified, unique resource identifier for this resource. And we'll talk a little bit later how this is better than just sending the raw IDs, because you can use cool things like HTTP redirects if this ever changes. It affords you a lot of power and flexibility, whereas a raw ID does not. So, yes?
So that means for put, you don't need the location because it's on the server side, you're actually finding the same object to update, correct?
So for a put, you don't need a location header because
the next time you send, you're sending the whole piece of data, so the server is going to find that object for you and update it accordingly.
Yes. You don't need the location header in a put because you already know the location of it when you send in the data to begin with. Right? So this helps the client understand where it resides. If you already know it, there's no need to put it in the headers again. So again, post is an update. It's not idempotent. You can send partial data. 200 OKs are perfectly fine because it's an update and you already have the fully qualified URI. We covered that. It's not idempotent. What about media types? This is something that comes up a lot when you talk about REST, and it's actually fairly important, really important actually to REST and how REST scales. A media type is really a format specification associated with a collection of parsing rules. So a client, a REST client, can look at a media type, and based on how that media type is defined, it knows this is the format of the data as well as how I know how to process it. How media types are identified or specified is completely outside the realm of REST. There's a number of ways to do this. Media types are IANA registered, IANA. So if you have a formal media type you want to register, you can go talk to IANA. Otherwise, you can use internal media types to your heart's content. But the reason why they're important is because they are the identifier of the format of how the data is transferred between client and server. So both client and server need to agree, or at least understand the same media types in order for data to be passed legitimately so both parties understand the data. And the way the client specifies to the server the kind of content it wants to receive back is via the accept header. So when a client sends a request into the server, it will set the accept header with a comma delimited list of the media types that it can support typically ordered in the order in which it wishes to receive the format or the data back. So in this presentation, you'll see our accept headers and our content type headers are application/JSON, which is the most common media type for JSON representation. And then, of course, on a response, the server needs to set the content type header to tell the client, the data that I'm sending back is the media type of foo or whatever it is. So ideally, the accept and the content header will be equal so that the data can be transferred in a format both parties wish to receive and communicate. They don't have to be, though. Maybe the client says, I accept both JSON and plain text, and the server, if it doesn't accept plain text, or excuse me, JSON, maybe it can send plain text back, and then the client would be expected to know how to process it. There's multiple representations of how you can specify content types, or media types, rather. The first is the most common one that we see all the time, is application/JSON. This just indicates that it is a generic JSON document with no additional information that gives you any kind of insight into what type of JSON document it is or what kind of properties exist, for example. You can specify custom media types, and actually Roy Fielding states that the heart and soul of REST architectures is hypermedia, basically linking between resources, and media types. And so you can have a tremendous wealth of flexibility in how data is exchanged based on how you link to resources as well as how you represent media types. So in the second example here, application/foo plus JSON, is a qualifier that says this is not only a JSON document, but it's a JSON document according to whatever the foo specification is. And so that can potentially give the client more information that says, not only is it a JSON document, but I know that I have to look for these 5 properties and that they do X, Y, and Z. You can further restrict via parameters on after a semicolon. So for example, foo plus JSON semicolon application is an additional restriction on what type of the foo JSON document it is. You can do name value pairs via ampersand, similar to query parameters. So you get a lot of flexibility in being able to actually specify exactly the type of content that's going to come back from the server. Most of the time, the real REST purists say that you should have media types, custom media types, for all of your data, because it's the quote-unquote true way to do these things. That being said, a more pragmatic approach is really to start off with application/JSON, and then as you have time, or as it makes sense to your project and or organization, then you actually define these media types and their parsing rules for clients. So,
are you going to go through examples of doing that?
Examples of?
Doing more specific media types when you're doing your demo and stuff?
I can. I mean, I haven't really baked it into this particular presentation, but I guess we can talk about that, I guess, in the second half when we can indicate how that can happen. So, okay, so those are really the fundamentals, media types, the methods, and we'll talk about some UR or some REST API design issues. Sorry. So the base URI, apologies. What looks better of these two? If you're a customer for a REST service, which of these two would you prefer to use? And what would make easier sense or more sense? Right, yeah. I mean, everybody says it's the top one, right? And so this is a minor point. It's not required, right? The bottom URL could be a REST endpoint. The point is that if you're going to make your REST API easily accessible to customers and or clients, and you want to facilitate and make their lives as easy as possible, choose a very simple URI, and it'll make them happy. And the more things that you do like this, the more adoption you're going to get on your REST API. And the easier it is, it's going to be for customer support and whatever. But things like this, really focus on intuition and trying to make things more intuitive for your customers. So we recommend going with the top approach. It's not mandate, but we've seen better results with people who think about these kind of things for their customers. An interesting question we get sometimes is, if I access this URI or URL from a browser as well as a REST client or command line client, what happens? A number of things can happen. You can return JSON specifically to the browser, or sorry, to the command line client, because maybe it sets that as an accept header. Maybe the browser specifies a whole bunch of things, and so if it accepts HTML and JSON, maybe you show them a full web page of that data. That's a completely viable approach depending on what the accept header is. we have chosen at Stormpath to have the JSON data shown in both scenarios. So even if you hit it with a browser, it still shows you a JSON document, not HTML. The reason why we did that is, again, for simplicity and ease of use for developers. As developers are tinkering around with your API and they're trying to test things out, they're going to want to see what the data looks like, not some HTML page, because maybe they're debugging something and they want to see the structure of the content. So our recommendation is that you make the URL return the same data type regardless of the client. Again, you have to respect the accept header, but given multiple options, return JSON at all times. Versioning. This is a particularly interesting topic in REST because there's a lot of debate about this right now. You know, if I've got version 1 of my API and version 2 of my API, how do I support that for clients? How do I represent that? There's really two kind of techniques here. The first is that you actually embed the version URI into your URL, or excuse me, the version number into your URL. The other is that you make it a configurable property of the media type that is configured by the client. So a client, if you're using the URL, it's obvious, right? You just go to that URL and you get back, and everything that stems from that URL down is going to return version 1's representation of the data formats. The media type approach is actually more elegant in that the client can specify what version that they want. And so what this means is that the URLs, or the URIs rather, for the REST resources never change over time, or they don't have to change over time rather. And that the client gets to choose the format version that it wants to receive. So maybe in version 1, there's a resource that has 5 properties. But in version 2, maybe one of those properties has been deleted. You don't want to remove that 5th property, or at least it's invisible. But you don't want to remove that 5th property because it might break existing clients. But the more up-to-date clients, the version 2 clients, can say that, you know, I understand that you've hidden that and that I don't need to process it. So give me version 2 of that particular JSON document, or that JSON resource. If you go the media type approach, by the way, is what Fielding and most of the REST community recommend as a best practice because it scales better, right? You can have any number of versions. Your URIs don't have to change. Your server code can easily distinguish based on version what kind of data to return. Whereas the URL being embedded or hard-coded into the URL is a little difficult to get around. You can use techniques like HTTP redirects, like if you change versions and you want to force a client to go to a different representation. There's ways to get around that. The reason why I bring up the top one is it seems to be the one that, from a pragmatic approach, that makes most sense to a lot of developers. Understanding media types and versioning of media types, as well as how to change your client code to parse different versions of data based on a version number, tends to be fairly difficult and complex for most developers. Like, you got to think a lot of the developers consuming these things are kids right out of high school or college. They might not know about these more in-depth techniques. So the top one tends to be the one that seems to be dominating a lot of the public REST APIs. And then you can duplicate functionality by adding a /v2 or /v3, you know, as your versions increase. And maybe they return the same representation, but your client never has to worry about that. So it tends to be easier to use on the top one. The bottom one is considered the best practice. So it's really up to you, depending on your client's needs and your customers. There's more complexity with the bottom one, but there's pros and cons of both approaches. Yes?
Is there any time the client needs to change when they change the new version here?
No. So one of the interesting things about the client needs to change when it starts. Oh, I'm sorry. Yeah. The question is, did the client need to change when the version numbers change, right? And the answer is yes. Like, ultimately, the client needs to know how to process that version. But a benefit of the V1 or you know, encoding it in the media type is that the client can choose when they want to upgrade. So maybe an existing library or an SDK only knows how to speak or use version 1 resources. That code never has to change as long as the server continues to support that version.
Yeah, that's what.
Exactly.
Existing clients don't need to change.
Yeah, existing clients do not need to change. But it makes it a lot easier for clients. Like, for example, what if you program URIs into your code for some reason, right? Your URIs never have to change in your code if you're using the media type version approach. So it depends on how this is a better impact to clients on the media type approach, whereas the top one forces a change no matter what. But it's easier to use, yes.
Is there any implications with caching between these two versions? Let's say I'm offering up version 1 and version 2, right?
Yep.
They have caching turned on and stuff. Is there any implication on the caching mechanism on a media type
Yeah.
versus the URL?
There's the URL, absolutely. So, the caching server has no knowledge of versions, right? So, V1 and V2 of the same resource will be considered separate resources by the caching server. The media type approach, I believe it's up to the caching server. So, and I think there are caching servers that allow you to configure whether or not this will invalidate a cache entry based on a version. But the top one forces an invalidation. So, so we just talked about this. Again, you can specify custom parameters via ampersands. So we typically, advise to go application JSON and then use the custom media type approach when you have time. Oh, one thing that I want to bring up is this notion of camel case. So when you represent resources in JSON specifically, and you're sending data back and forth, JSON stands for JavaScript Object Notation. So you want to make sure that the data represented in your payload uses JavaScript conventions. So instead of having a for underscore each or given underscore name, use camel casing. It's what the JavaScript convention is. And not only that, but this is also directly portable with any JavaScript-based user interfaces that might need to consume this information. So because it's a convention, any JavaScript UIs can just use these properties directly from the REST payload without having to convert it into a format that's easy for them to use. So common for Ruby, unconventional for JavaScript. Stick with the JavaScript notation. Consistency helps integration. What about dates, timestamps? It's interesting because there's a lot of ways that I've seen people represent dates and times in their REST APIs. And it's a little interesting to me because there's already a standard, and there's been a standard for decades. It's ISO 8601, and it's a date timestamp format. If you keep all of your timestamps in 8601 representation, it will be much, much easier to deal with over time. Libraries already know how to support this on both JavaScript side and most REST frameworks. Like, for example, Jackson, when it processes JSON, knows how to parse these already. We also like to recommend to represent all times in Zulu or UTC. And the reason why is because typically for most REST APIs, or especially publicly exposed ones, you have clients from all over the world. And so it's a lot harder to try to support and or calculate times and representations of times depending on where the client might exist. If everything is done in UTC, Universal Time Coordinated Time, then it works the same way for every client. And then they can choose to represent those times in a different format based on where they might reside. So we've seen a lot of problems with timestamp representations being non-UTC. Like, for example, a lot of databases like MySQL in specific do not do very well at all with maintaining timestamps in the database. So if you have UTC from the database all the way up, it will greatly simplify your code. And it makes things easier for the client because they always know what to expect. So stick with 8601 if you can. There's not a whole lot of reasons to diverge from it. So hrefs, one of the things that's really, really critical to REST architectures in general is this notion of distributed hypermedia. And that really just means resources that have references to other resources. And even across systems and heterogeneous systems, third parties, this is probably the most powerful thing about REST architectures is that you can reference data no matter where it might reside based on hrefs. And so we like to suggest that every accessible resource has a unique URL. Every single one that you serve from your REST API as a resource should have a unique URL. And this effectively, as we had a question before, replaces the notion of an ID. IDs still exist, but they're really internal to your service and they're opaque to the client. So while they might see an ID, they might not know how it functions or why it exists, because the ID of the record for the client is really the href property. And so we advocate that you put an href property. Well, first of all, there's any number of ways to represent hrefs and links to other objects in JSON. And there's a lot of competing kind of techniques and standards or semi-standards that are going on right now. We recommend putting it as a top-level property in the object. And we believe it to be critical for how objects or resources are linked And I'll show you a really specific use case of where this is particularly elegant. So we always like to make sure that there's always an href. So no matter what resource you're looking at, the client can always assume that it knows how to get back to that data. What's the question?
I mean, this one has a version in the URL, but if you do the media type versioning,
Yes.
that'd be a way to represent it.
So this would not be, so the question is this one has a version embedded in the URL, but what if you were using the media type approach? How do you represent that? And the answer would be, it's more likely you would have another property that specifies the media type so that they know how to look at it. Again, that's up to the media type, right? You can specify what the properties are, and you know how to parse it accordingly. So the response body. Sometimes we get questions about this, like when should there be a response body? With GET, it's kind of obvious, right? If I'm getting a resource, I want the body back no matter what. So that's kind of obvious. But what about POST? So if I send data into the server, should the response be that exact same resource that spit right back out to me? Like, I just gave it to you. Why are you sending it back to me? Is that necessary? There's a lot of, it simplifies code to a great degree for the client if it knows to expect a resource every time it sends a request. So if I'm sending in, maybe a user object or user resource, and I only change the username, and I know that the data that comes back is sort of the freshest or most accurate or version of that user resource, then that means I can change whatever I might have locally to represent what the server just sent back. And so we kind of feel that although it's not necessarily necessary, that it's a good convenience, and most REST resources aren't large enough to the point where this would cause any problems. That being said, this would be a problem, for example, if you're, say, posting a video. Right? If you post a video, you don't want to send the video right back out to the client. Right? It's a lot of data. It's not necessary. So use prudence and judgment as necessary, but we find that this simplifies a lot of client-side code or client-side SDKs because they always know that they have the most recent version locally. You can also, if you want to, support a query parameter like _body equals false that allows the client to control whether or not they want this to occur. Again, remember, if you have a quota-limited API, for example, maybe you don't want to send the data back because it eats against the client quota. So you could add control parameters to your query string to allow that to turn on or off or not. Content negotiation. So we talked about this a little bit already. The default way for a client to get back the data it wants is to definitely use the accept header. And this is the expected and conventional way to do it. And it's actually part of the specification. This is the way most people do it. And again, header values are comma delimited in the order of preference that the client wishes to receive that format. But there's something that's also convenient for maybe REST clients that are a little older or may not be able to support headers for whatever reason. Excuse me. And that's setting the IANA registered suffix or extension for that media type as part of the actual URI directly. So in this example, you see that it's the same resource on the server, but the representation is different. One's a JSON representation, the other's a CSV representation. And if somebody does this, this will conventionally always override the accept header. So if they specify both, you always choose the one, because the URI is the most relevant part of the request. So you use that and defer to the accept header if that's not specified. So how do we handle linking? So again, this is one of the most important parts of REST APIs. Right? Hypermedia is paramount according to Fielding. And linking is fundamental to scalability. And again, here I'm not talking about performance. I'm talking about the ability of the data to be used by heterogeneous systems in many different contexts. Right? That's the kind of scale that we're talking about. But how do we do this? It's kind of tricky in JSON. XML already has this built into in one of its specifications, and it's got a W3C standard called XLink that actually standardizes how references to other resources are encoded in XML. JSON has no such concept, right? Again, this is one of the things that are being heavily debated on the net right now. But because there's no standard for it, how should we do it? So in this example, I've got an account resource. It's an instance of a particular account, and I've got some data. I've got the href, which is the global identifier. I've got given name, surname, maybe some other properties. And then there's this directory property that, for example, in Stormpath's API, this tells the caller the directory to which that account belongs. Right? A directory is a container of accounts. So how do we reference the directory? So before, when we were talking about the href property, this is where we feel that it starts to kind of show some of its elegance. So while this is a little different in XML, XML has a relation attribute, rel, right? You can do a rel equals or whatever. And the relation is really describing the type of relationship that's kind of already implicit in JSON. Like the property name itself is the relation. And so it's implied that for a directory, if it's got a single property, which is itself a complex object, and that object has a single href property, then you know that for that property, where to go in order to get that actual data representation. So this is how we're doing linking in our REST API, and we'll actually show a technique called entity expansion a little bit later that makes this even more elegant. So we've researched probably 8 or 9 different ways of representing links, and we decided on this one after a lot of internal debate and research. And we found that this actually is one of the most elegant ways, and it scales really, really well. And I'll show how in just a second. So this is an instance to a particular directory, or sorry, a reference to a particular directory. The same can be true for collections. So it's the same account, and instead of the directory, maybe I want to find out what groups that the account belongs to. And so in this case, I've got a groups property, and it itself is an href to the fully qualified unique identifier of the group collection. Remember before we were talking about there's really 2 kinds of resources. There's an instance resource and a collection resource. This is just a link to the collection resource itself. Whereas the directory one was a link to an instance resource. So reference expansion. This is, whoa, that's kind of weird. Maybe I got static or something.
I have a question.
Yeah, question.
On the previous slide, you chose to nest groups under accounts. So why was that chosen rather than making groups in the top level?
So the question is in the URI for the groups property, we've chosen to nest groups under accounts, right? As opposed to why weren't the groups represented as their own top level kind of collection, right? And the answer is we do both actually in the Stormpath system, right? So groups as a top level concept represents all groups for your particular tenant, every group that's in the system. Because we feel that without any additional qualifier, groups is generic, and therefore the representation should be generic, and that it hits every single group. This URI here will return a collection resource that represents only the groups for that particular account. So reference expansion. This is also called entity expansion or link expansion on the net. So I showed you before, we have an account, and we showed you a link to the directory. But what if for, I don't know, bandwidth reasons or network overhead or just for simplicity, I wanted both the account and its directory in a single request? How would you do this? In all the research that we did, we found that one of the most elegant ways to handle this and flexible ways is to support an expand directive as a query parameter. And so in this case, we're getting the same account resource, but we've set expand equals directory, and that's a directive to the server that when the resource is returned, that not only is all the accounts name value pairs returned, but I also want you to return the directory, and I also want you to expand the directory in its entirety so I don't have to go back to the server to get the directory. This is really valuable, especially for a lot of user interfaces, because you can customize what your UI screens look like based on directives to the server, so you don't have to have multiple round-trip requests, and it will actually improve performance quite a bit. Yes, question?
This expand directive was invented by you, or is it standardized?
No, it's not a standard. We've seen this technique used in other APIs to a certain extent. I can't remember if we came up with the expand word or not. This is the thing that made the most sense to us, so we went with it. We also have the ability, like in our API, expand equals star, and that says expand every single property, or expand equals directory, comma, groups, and that says only expand those 2 properties within the account. So the server, you get a lot of power for the client based on what the server is willing to support. I should also note here that it's actually really important to note for caching purposes, query parameters are taken into account for caching servers. And so while this represents the same resource on the server, the request without the query and the request with the query are considered 2 separate resources by the caching server, even though they really represent the same source under the hood. So just keep that in mind for caching rules if that's important to you guys, or for whatever your domain is. Yes?
What about nesting? If you do like directory, but you have something inside the directory, and you would like to have this nesting, like not the first level, second or third level of nesting.
Right. So the question is how do you support or potentially handle multiple nesting levels? So for example, maybe I want the account and its directory, and also from within the directory, I want the applications that are associated with that directory. How do I get all of that data? Essentially a tree. And the answer is that it's really up to the server as to how many levels you go deep, because the more levels you go, the higher performance penalty you're going to incur, depending on the data source. The way we do it is kind of based on parentheses. So you could say expand equals directory, open paren, applications, comma, whatever, and that gives a list of things. So we've kind of built up this expression grammar, if you will, that allows the server to know how much data to pull back. But it's at the server's discretion as to how or what endpoints support this level of nesting. Right? It's not necessarily arbitrary for the client. The server has to be aware of it.
At this point, when you will go to your code examples, would you show like how you handle this, like I don't know, errors or
So in the code that we have to show today, I do not show that particular use case, because to do a demo in an hour to write that level of grammar parser would be very, very difficult. But maybe we can post something up on the GitHub project that we have in the future. So the GitHub project that we're going to demonstrate does not have that, but it shows a more simplified version of what that might look like. So we'll show that a little bit later. So this is, again, we call this resource expansion. It can be very powerful depending on what the client wants. And again, the server doesn't necessarily know what the client wants, so it should support, depending on your performance requirements, a certain level of these depending on the REST resource.
Question.
Yes?
So as a principle, what would a server response be when you actually do a get on a high-level object, like you do a get on just accounts?
So if I do a get on just accounts, you mean the one particular account? The default response for us is the bare minimum representation of that object. So here you see that we have the object and all of its properties, and then links to any of its.
No, I meant just without even the ID. Just do a get on the account.
Oh,
The whole
okay.
collection, or you just say because of performance, you just say that,
So it depends. So the question is what if I just did get on /accounts and I don't have any qualifier? Do you return every single account? And the answer is that it depends on the server, it depends on the URL, like on your endpoint. What we do is we default to a collection resource that has a maximum limit of 25 items. And so actually, it's a little more complicated than that. We actually do a redirect to a URL that represents that collection resource. Because if you were to actually satisfy a /accounts, you would expect to get every single account back in the entire system. For us, that could be millions, right? And so we don't actually support that operation. We default to a paginated response. Yeah. And we'll talk about pagination a little bit. So I just explained how to get an object and its and additional data for its relationships. What if I only want to return back a little bit of data? And again, maybe because of bandwidth reasons or what have you, or very concrete specific use cases, you only want to return a certain amount of data back. You could also support a fields query parameter that allows the client to only return or only receive the data that they actually care about instead of the entire resource representation. I'm not saying this technique needs to be supported by everybody. It can make sense depending on the problem domain. So maybe this would be useful. So in this case, I would return an account object with only 3 properties: the given name, the surname, and the directory. And here with the parentheses, you see that the directory's name is expanded as well. So you can kind of mix and match expansion and restriction to give you back a very customized view of what you want. Yes?
Can we do like return a collection with certain fields?
Can you return a collection and
Like I just want get the CN, get the account.
you mean just get the accounts or properties within each account?
Yeah, just a certain attribute.
Yes. So the question is, can I get in a collection, for the elements in that collection, can I get back certain elements or certain properties on those individual elements? And the answer is yes. It depends on your parsing rules and what kind of parsing techniques you support. But if we had an expand parameter and we specified directory and then we said fields equals X, Y, and Z, then for each directory element in that collection, it would only have those 3 properties. So again, it's up to your parsing rules and what you want to support from a performance perspective. So pagination, this is kind of segue into that question. How do you support pagination? So every collection resource we feel should support query parameters that specify an offset, which is your starting position in the overall list, as well as a limit parameter, which specifies the maximum number of elements to return in the collection. So if I were to go to /applications/offset50 equals limit 25, that means I want to show the page starting at the 50th element, but show me no more than 25 items. So here's an example of what it might look like if I go to the group resource, or sorry, groups for an account, and then I would list the items collection, no more than 25, because that's the limit. We also do something for the HATEOAS kind of acronym. We provide first, next, last, and previous links as well. And the reason why is because the consumer of this endpoint doesn't, if you look at this response and this response only, the consumer doesn't know how to pick up any of those URIs and chop off a piece and stick in the offset and the limit parameter. It doesn't know how to do that stuff. You could, via a media type, specify that, hey, if there's an offset and a limit parameter, look for the base href, and then you can use that base href and then specify these 2 query parameters. The media type actually would specify those parsing rules. But if they don't know that, they still have properties that they can use to actually go get other pages in the collection. How you structure your pages and whether or not they're sequential or first, last, it's completely up to you. This is just one technique. Yeah.
So I noticed in like the previous, it's no, there's no previous result set.
Yes.
Are you guys always very specific in your return to do that? So like in a prototype I did, I would just let the previous off.
Sorry.
Just to always be explicit.
Yeah. So the question is in this case, we have a previous field which is null because there's no previous pages in the query result set. And so if that's the case, why not just leave the property off, right? And the reason why we choose not to do that is because it has been my experience, especially I wrote a lot of the SDKs that wrap our APIs, and our SDKs and even the JavaScript clients, it's more difficult for them because they have to see, does this property exist or not? So there's a lot of conditional branching that just doesn't need to be there, as opposed to it's always there. I'm always going to check it. If it's null, then I know that I'm at the beginning of the result set. So the less, I forget what they call there's a statistic, the computational complexity of branching. The less that you have of that, the less bugs that are introduced, the easier it is to build and test against. So we try to return the data all the time to make sure that they don't have to do a bunch of if-else checks in their code. So this is the first representation that we've seen of what a collection resource looks like. And you might have noticed a bunch of times I've been calling this a collection resource, not just a collection. And the reason why is that if you look at this, it itself is its own resource. And it just happens to encompass a collection of items, right? So instead of returning a JSON array, right, open bracket, close bracket with a bunch of items inside of it, itself has a bunch of properties, and then it has an internal items collection. So the whole thing is a resource first and foremost. It just happens to contain more resources via the items collection, or the items property inside the resource. So that's why we always say collection resource versus instance resources, because they're both resources first. Whether or not they have children is another story. Yes?
Do you restrict the limit size if they ask for 1 million?
Yes. So the question is, can you restrict, or should you restrict the limit size? So if they say the limit's 1 million, they want 1 million responses back. Yes, in our code, we actually have a maximum amount. So while the limit defaults to 25, we might go up to, say, 500, but we won't allow anything beyond that.
So that's a parameter validation, right?
I'm sorry?
It's a parameter validation.
Parameter validation. Yes, absolutely. Yeah. So we don't even validate it. We just say, give me the math.max of whatever our max is and whatever, or math.min of whatever ours is and whatever they specified. Yes.
Isn't it better in this case just to fail? Because then in the cache you will have one entry with limit 1 million and the other same entry with limit 2 million.
So the question is, isn't it better in this case to fail? Because if you're using caching and one has a query parameter for 1 million and the other has 2 million, then it's, I think it depends on your use case. They're both considered separate resources in the cache because the query parameters are different. So if that has no adverse effect on your client, then there's nothing wrong with it. Like it really depends on the problem domain. Maybe that would cause a problem for input validation for some services that had to have strict kind of terms of service. But for ours, for example, we have no such restriction because it doesn't hurt anything. Then again, one of the other things is because we're a security service in the cloud, everything that we do is over SSL. So unfortunately, even though I tout caching, we can't really use it because everything goes through SSL on our servers because we have to support things like PCI compliance and other things. So to that end, we go through a great deal of caching work on our end behind the web server to alleviate a lot of this pain.
Another question?
Yes?
The href here it is relative.
Actually, no. The question is, the href here is relative, and it's not really. It's really an ellipsis, ... just so I could fit it on one slide. In our API, all the hrefs are always 100% qualified, and the reason why is we want the client to be able to take that property and execute a request immediately with no problems. Yes.
Why not put the links inside the headers?
So the question is, why not put the links inside the headers, right? It's a good question. It's a valid approach. The question of whether or not you support multiple or custom headers versus properties, for us, really came down to, at the end of the day, is it's more intuitive and easy to use for most developers. Like, if I don't have a special REST client, and all I have is a browser, I want to be able to see everything I can do immediately without having to use curl if I don't have it on that box or whatever. So that's really it. And one of the other things too is that for the client, we wanted all of the relevant data for a response to always be in the body, so they didn't have to look anywhere else. And it simplifies programming techniques because you don't have to check multiple places. It's always in the data set that's respond. It's always in the payload. It's not necessary, but we did it out of convenience, and we found that people like that. So,
I have another question.
yes.
Have you looked at RFC 5005 for your pagination?
Have I looked at RFC 5005 for pagination? I have not. Well, that's probably not entirely true. I've looked at so many RFCs in the last year that I can't remember what 5005 is.
That's when it has the next equals number, then ampersand 2 item, and then you can have inclusive, non-inclusive, true or false boolean.
Oh, right. Yes, I have seen that one. It's interesting. I think it's a good technique. The point of that RFC, I think, is really to standardize on a technique for pagination. And barring any other de facto standard, I think it's fine. What's interesting to know here about pagination can get really tricky if you guys have a NoSQL backstore, right? You can't use database cursors, on certain NoSQL data stores, or actually most. So how do you represent pagination? And that's a tricky problem. There's ways to do it where you actually chunk up the data, where you actually duplicate data and say there's 25 in this bucket and 25 in the next. you have to invalidate those entries as records are updated. So it can be kind of hairy depending on your data store, but that's way outside the bounds of this presentation, so I won't really talk about that here. Yes?
When you're querying the group, you implicitly sort the items, or
So when
just return around?
when you're querying the group, do you implicitly sort the items? That's the question. It depends on the item collection. So for example, certain items in our data store are lists, right? And so they have an inherent ordering to them already, and those would be returned in the order that they're stored. You can specify ordering based on query parameters, and that's the way that we would recommend it. The difficulty there is, again, if you adhere to the HATEOAS type of mentality, you would essentially need a link for each one of those sorting options, because the client doesn't know how to construct a query. So you need to have a link that says these are all of your sorting options. And that's actually maybe not that bad. Maybe you have data and there's 5 or 10 fields that could be sortable. You just have 10 additional links in the payload. It's not that much extra data to support. Again, that's a restriction on REST architectures. You could still be RESTful without HATEOAS kind of techniques, but the purists like to stick to that. Yes?
Without the implicit sorting, though, the offset doesn't make sense.
Without implicit sorting, the offset does not make sense.
Right? Because if you say, oh, I want 0 through 24, and then I want 25 through, if they're coming back random, then...
Oh, yes. You're absolutely right, sorry. Our queries that we execute on our backend always have sorting enabled because of the offset and the limit issues. We don't necessarily expose that to the client, depending on the resource. Some of them might be sortable. So in this case, the items just happen to come back in the same order at all times, even though on the back end we have a query that does specify ordering. But it's not exposed to the REST API client. And you guys will also see when we start dealing with code, we tend to use linked hash maps a lot in our Java code to represent JSON payloads, because they do retain order. And while it's not required, actually JSON specifies that order is not guaranteed. We find it to be convenient for clients that might want to rely on that behavior. Or the way information is presented in the browser is a little easier or more aesthetically easier to consume by the developer. Question?
Going back to where you were talking about all that, the application type where you said food, application
Mm-hmm.
how do you typically provide the specification for the contract? I know with XML you might say, okay, there's an
XSD, right.
But like with JSON and the other formats that you can do, what are some best practices that your company has applied?
That's a really good question. So the question is before we're talking about custom media types, and a media type is a data format and a set of parsing rules associated with that format. So if the data payload was XML, how do you specify the media type's parsing descriptions? Typically in the XML world, you fall back on an XSD to do that. Whereas in JSON, there's not anything really like that. And the unfortunate answer to that is that there are no techniques that are widely accepted. It's like we've seen media type parsing rules is literally, a proposal for an RFC that says you look for this before you look for that, before you look for that. And it's literally an algorithm drawn out in human readable text that you have code that implements. There's also, I think, an effort for JSON schema, which allows you to write schema definitions in JSON. It's kind of funny because it's like XML already has that down pat. Why are you reinventing the wheel? That being said, the media type definition and its parsing rules are completely orthogonal to the actual representation. So it's totally within the realm of possibility, and maybe even advocated that is defined as XSD, whereas the JSON is the payload. But there is no spec, and there's no widely acceptable standard of how to do that. So many to many, this is a question we get that seems to cause a lot of questions and confusion. If I've got an account and it has many groups, and I've got a group that can contain many accounts, how do I represent that in a RESTful representation? So for us, each one of those mappings is itself its own resource. So we have this group membership concept that actually retains a link to both of those entities And while our internal data model and the backend system may not necessarily be identical or have a one-to-one correlation, the REST resource representation does represent it as its own entity. So here's an example. If you access the group memberships with a unique ID, you'll get back, again, it has its own href, its own globally unique identifier, and then it itself has 2 links to the things that it's correlating. A benefit here is that in addition to just referencing the account in the group, you can represent a lot more information, like maybe who is responsible for associating these 2 things, or the time that it was created, or when was the last time this relationship was updated. There's any other amount of metadata that you can represent in the backend system can be represented via this membership mapping. And so in the account resource, you'll actually see that we represent groups and group memberships as 2 separate links. Because maybe in some contexts or some scenarios, the client doesn't care about that additional metadata. All it cares about is give me just back the groups. Whereas some contexts, it might say, you know what, not only do I want to see the group memberships or what groups that they're in, but I also want to see who created those groups, or what time that those things were created. And so 2 links are a part of the account resource. The client gets to choose the granularity or the scope of the data that they want to see. So it also helps with backwards compatibility. So for example, maybe you didn't have a group membership concept in your data model, and you only had a direct association with groups. You can add a group memberships link later when you introduce that concept, and it doesn't break the existing functionality built on top of that link, or the groups link. Oh, one thing I should note on versioning is we only increment version numbers when there would be a backwards incompatible change. And so for REST resources, we will add properties all day long to our resources without incrementing the version number because it doesn't change what the client expects to see. What's that? Yeah, we're not taking anything away from the client, so it's not going to break their current functionality. So we will add things, but we will not remove things without incrementing a version number. Oh, I guess the other thing I forgot to mention on the versions is that it should be noted that versions are, they should be fairly coarse-grained, right? You shouldn't be incrementing version numbers in your APIs much at all. So you shouldn't have version 1.1 and 1.5 and 1.12 and 1.24, right? Those things should change so infrequently that that whole-based integers should be more than sufficient. If you have like version 23, that might be a problem because then it's requiring clients to change too much.
Your href for that group membership looks a little different than I would expect in HATEOAS stuff. And the fact that you have an end account ID is equal to that instead of actually getting the group ID's unique ID, and then putting that in as the thing,
Oh, right.
Maybe if you go to your previous page, you had /group membership / and then some ID.
Right. Yeah, and that's because the question is the group membership URL looks a little strange in that it's got a query parameter, not a child reference. And the reason why for us, group memberships are a top level concept, right? They can represent all groups across all directories across all accounts, and so we're limiting the scope of their query results to be based on that particular account and that account only.
Account ID is an attribute of that resource.
Yes, exactly. Errors. This is actually a really cool topic, and it seems to be something that's fairly overlooked in a lot of REST APIs. The point with errors that I want to convey is that you really want to be as descriptive as possible. You want to give as much information as you possibly can to whoever's consuming your REST API. Developers are your customers, whether it's internal or external. The happier they are and the easier that they can debug problems, the more likely they are to continue to use your service and be happy customers and maybe refer you to other people. So you want to make this as painless as possible. Like one of the biggest things that will turn a developer away from your service if you're commercial is if they're having problems integrating. And so the more information you can give them, the better. So what do I mean by that? So for example here, we're sending a post to the directories endpoint, but I'm creating a new directory and I'm calling it the Avengers directory. And in this case, Avengers already exists in the system. And so the response is actually a 409 conflict to indicate that there's a conflicting resource already on the system. What is that thing? Sorry. It's the cable. Sorry, guys. I will not move. Don't, no. So when we show a REST error, we show a bunch of information. One is the status, which is...
Podium, and I'll switch this one out, or?
Yeah, that's fine. I can use a podium.
Okay, let me turn that up.
I'm not touching those wires. Maybe not. Maybe it is me. Maybe I got too much static. Is that okay? Nah. Okay. Static electricity.
Check, check. Is the lab up?
Check, check. Yeah, thank you. Yep, no static. Is that okay? You guys hear me back there? Thank you, appreciate it. Okay, so we want to give them a lot of information, and so in keeping with the theme of keeping as much information as possible in the payload, we actually have a bunch of properties that come back during an error. The first is the status code. It's the same as the HTTP status code. They don't have to go to a header if they don't want to figure out what's going on. And also it could be used, if you're generating a report, the information's there, it's easy. We also have this notion of an internal code, which is a further extension on top of the status. And the reason why we do that is that I think with the 400, the 4XX error codes in HTTP, I think there's only 15 or 17 of them, and in the 500s, there's only 6. So 500 through 506. And that's really a maximum of, 23 odd kind of error codes to indicate a whole wide range of things that might have gone wrong. And so we also produce or provide at times a code that gives you even more information as to why something failed. That can be used, by a programmatic client to further provide more information to why something failed. In this case, the property that failed or that caused the failure was the name property on the directory resource. Here's the message, and the message for us is something directly exposable to an application end user. So the developer can actually take this message property, and if they're building a JSON-based application, for example, show it directly to their own end user, right? And that's a really nice convenience for people consuming your APIs because they don't have to worry about how do I show information to end users in a way that makes sense. So the message property is a concise, fairly clear, human-readable message that can be shown to basically anyone. And the developer message further gives you additional information as to why something might have failed that's relevant for a developer only. So if they see this in their stack trace, for example, they can actually get more information beyond just 409 to figure out why something failed. And then finally, one of the most important things is we have a more info property that gives you a fully qualified link to that particular error code. And I can't take credit for this, by the way. The Twilio guys, I think, kind of really spearheaded this approach in their own API. But the beauty of the more info property is that if you link to a page that you host, you can do all sorts of things, right? You can have a forum on there. You can have, chat now, help me fix stuff, or here's a whole bunch of information as to why this occurred, right? You have a tremendous amount of information that you have at your disposal for your customer that can really help them through the problem. And the more resources you have at their disposal, the more likely they are to stay with you as a customer. So you have a lot of power and flexibility here. This is a really clean way of supporting errors.
Question?
Yes.
Is it convention to prefix your code with your status?
Is it a convention to prefix code with what?
Your status. You got 409 and 409.
Oh, is it a convention to prefix the code with status? It's up to you. This is actually not a message, an error response that we would return from our API. I just threw it up there because it made sense, or at least it made sense to me at the time that I was writing the slide. But that being said, I think it could be a good idea. If you have multiple reasons why something would conflict, I don't see any reason why you couldn't just extend beyond that. If the HTTP status codes that exist are already a good delineator on segmenting your errors, then I think that would be a good idea. If they're not a good segmentation of your particular error conditions, then probably not.
Would you ever invent one yourself?
Yeah, absolutely. So I think...
Would you ever invent a new status?
Could you ever invent a new status? No. No, yeah, only if the HTTP spec is refined, right? For us, at least, the code or the status here always reflects the HTTP status code. The code is really where you have freedom to do whatever you want. Okay, I'm going to kind of fly through this a little bit more so we can actually look at some code examples. So we'll talk about security. One of the interesting things about security for HTTP and REST is, people advocate it as a stateless platform or paradigm. So that really means, trying to keep sessions or avoid sessions at all costs if you can. And what that usually translates into for secure services is that every request that comes into your system is going to be authenticated somehow. It's also important to authorize based on resource content, not the URL. And the reason why is URLs can change over time, right? You have the freedom and the liberty as a REST designer, especially as your REST API matures and maybe certain parts are decommissioned. You can use HTTP redirects to move users from one URL to another if the resource has changed. So you don't necessarily want to authorize based on that. You want to authorize based on the actual resource content itself. Yes?
Are you using temporary or permanent moves?
So the question is, are you using temporary or permanent redirects? All of ours are temporary because we don't know, at least yet, as to the longevity of a particular move. If you're going to authenticate users, we recommend that you use, there's a couple approaches. One is you use an existing protocol. So there's OAuth 1.0a out there. There's OAuth 2. I should kind of point out that OAuth 2 is sort of a misnomer. It is the next version in the specification process, but it's not actually necessarily more secure than OAuth 1.0a. OAuth 2 sort of, they kind of bypass the authentication step by forcing things to go over SSL and then using a bearer token for the remainder of communication for each REST call that goes through the system. OAuth 1.0a can actually authenticate the headers and the payload on every single request. It's actually very, very secure. If you have to, you can use HTTP basic authentication, but never ever use it in any scenario other than HTTPS. It should always be over SSL, no matter what. Another approach, and this is kind of one that we do at Stormpath, is you can create your own custom authentication scheme. This is specifically supporting the authorization header in the HTTP specification. Only do this if you really, really, really know what you're doing. Because if you create a custom authentication scheme and you're not a security or crypto expert, you can have significant holes without you knowing about it. We're security guys at Stormpath, and so we do have our own authentication scheme. It's very similar to Amazon's version 4 of their authentication scheme. Ours is, we believe, a little more secure because we use a nonce technique to prevent replay attacks, but sort of outside the scope of this presentation. But the point is, if you create a custom scheme, the problem with that is it's not standard, and it's not necessarily widely adopted. So if you do that, make sure you have SDK clients that you build and you distribute that will implement that authentication scheme automatically for your customers so they don't have to worry about all the crazy crypto that is necessary. Again, only do this if you really know what you're doing and you're comfortable with it. And unfortunately, this is a whole nother presentation, but you should always use API keys instead of usernames and passwords. If you use a username and password for your API and the user changes their password, any client using the username and password pair now no longer works. Right? It's very, very brittle. API keys can also be rotated over time. They can be decommissioned if they might have been compromised. There's a lot of really good benefits for using API keys. So we recommend using API keys and not username passwords that are directly tied to a user account. So we've seen the schemes. I'm going to kind of fly through the rest of this stuff. Yes, question? Authorize based on a resource content. Show an example of that. It's kind of hard. So I guess I should say that in addition to this stuff that I do for Stormpath, I'm also the PMC chair of Apache Shiro, which is the Apache Foundation's security framework. And Apache has very specific ways of doing this, or Shiro has very unique techniques of doing this. You can do it differently with Spring Security. You can do it differently with Jazz. There's a lot of different ways to do that. So it's kind of hard to come up with an example that kind of applies to everyone. What I was really saying is that URL or security techniques or authorization restrictions based on just the URL name is probably fairly brittle. Because if that ever changes for any reason, your security policy might break. As opposed to saying, I'm restricting this resource, which is document ID 123, and then you restrict the resource not based on the URL, but the actual content. And that's largely dependent upon your security framework. So
Basically what you're serving as opposed to how you're calling.
yeah, it's what you're serving as opposed to how it's called, right? That's the real key takeaway. Authentication schemes, right? The server will issue a www authenticate header, and the client responds with the payload that's expected, or the header value that's expected for that particular scheme. You'll see OAuth, you'll see basic, you'll see digest, you'll see Stormpath's custom one. This is the handshake that's required for authentication in HTTP. So, one thing that's kind of important to drive home is the differences between 401 and 403. These are sort of unfortunate, right? 401 unauthorized, as the HTTP spec specifies, it really means unauthenticated, not necessarily unauthorized. It means that you need valid credentials in order for you to continue on to this resource. And 403 forbidden really means unauthorized, like you do not have permit. Yes, I understand your credentials, but you still don't have permission to access the resource. So those are the differences between 401 and 403. They're important to understand, especially in the context of security APIs. API keys, I talked about them a little bit. Because they can be a lot more complex, they have a higher entropy. So the entropy space for API keys is much, much larger than your typical 8 to 13 character passwords. So therefore, they're harder to break, assuming you're using salting techniques and stuff efficiently. Again, if you reset a password and your API keys are based on passwords, now all of your API clients break that had that password. And you can kind of reduce exposure. So for example, in Stormpath, if you use an API key to access our service, you download that API key to your file system, and it's stored securely there. We don't ever advocate copying and pasting keys into code, and everything should be external to the code base. So you can kind of get limited exposure based on API keys where copying and pasting values might not be a good idea. If you have questions about this stuff, let me know after the presentation. IDs, I had mentioned before, they should be opaque. They should kind of be globally unique. As you move to more NoSQL types of systems these days, when you can have globally unique identifiers, time-based UUIDs are a good technique. Anything that can be globally unique. We recommend that you avoid sequential numbers. The first reason is really from a contention issue. If you're in a clustered distributed API service, you've got multiple web servers, and you have them all trying to access or create IDs at the same time, you could have a contention issue, right? If they're all trying, you basically have to have a single source for that identifier, or a single number or sequence generator. That could be a point of contention depending on the load that you get on your system. It can also be used as a fusking technique, and fusking is a technique where maybe I see URL that ends in /23, and then I try /24 and then /25 to see if I get access to information. You want to just eliminate that possibility up front. Your API still should be secured based on the identifier or the content of that data, but this just helps eliminate certain attack vectors. UUIDs, we have something internally called URL64, which is basically a 64. It's similar to base 64, but it doesn't contain any reserved characters, so they can actually exist inside of URLs. So anyway, good IDs. How do you do method overrides? Sometimes this is asked by people that have to support older HTTP clients that don't support maybe delete or put. You can specify a method query parameter, and basically what this does is, you can set up, for example, a servlet filter that just inspects this and changes the method to post or delete instead of post. If you do overriding or overloading from delete or put, it should always be based on post, right? Because it's idempotent and the server it's legal to do this. It's not legal to override it via put. Caching and concurrency control. HTTP has as part of the spec has this notion of Etags, and an Etag is really a unique version number. And so what's beneficial about this is if your response has an E tag, the client can send a response later or a request later to saying, give me that data if there's something different than this version number that I'm sending you. And so if it hasn't changed on the server can return 304 not modified with no body content. It's a lot more efficient to do this, and you don't have as much data going over the wire. So clients, proxy servers, they can support this technique. So if you support unique version numbers in your resources in the server, you can support a more efficient caching infrastructure. Again, for us, everything is over SSL, so we can't really utilize this as well, but we can use the E tag as a mechanism to trigger our own caching on the back end. Maintenance, so once your REST API becomes more mature over time, use redirects. It's part of the spec. Clients should be expected to handle them. If you want to move a URL pattern, from /accounts to /tenants/accounts or something like that, you should be allowed to do that as an architect, and clients should be expected to handle redirects accordingly. You can create an abstraction layer, so you can have basically a set of controllers that support version 1, and maybe they redirect to version 2, or internally they call functions for the version 2 controllers. You can use these techniques to mitigate change to existing clients or reduce the impact of change to existing clients. And then finally, use well-defined media types if you can. Okay, any questions on this stuff before we start looking at some code?
I have a kind of question. So does using REST kind of increase the number of tables or schema objects that in your system, because most of your actions now are represented as resources? So what's the experience?
So the question is does using REST increase the number of tables in your database schema, for example? Excuse me. So what is kind of the...
For example, like we have asynchronous operations, and so if you used a SOAP-based service, you would just trigger that operation, and then you have a poll, and that would return the status of that operation.
Right.
And now with REST, you need to kind of create a resource saying this is a request resource, and then you need to check the status of the request. Again, you need to kind of poll that.
Yeah, you can do that. I mean, with idempotency, you can leverage puts, especially gets, and of course the not modified, or you can send 2 or 304 not modified. Those can be used to support asynchronous APIs. But the point from the web server's perspective is that it has to give a response based on its current state that it knows about when it responds to that particular caller. So it doesn't really care whether or not the client is async or not. The client for async environments has to adapt to integrate with these patterns. Yes. So we didn't cover localization. The question is, how do you guys handle it, or have you given localization much thought? And the answer is, we currently don't address localization. In other words, we just regurgitate the data as it comes into us. However, on messages, our error codes, those will be localized for whatever based on the locale header that comes in on the request. Yes. So, have I experienced or found any query patterns or query mechanisms for REST-based APIs? Querying a domain model. No, not really. I mean, it's interesting in that the only querying that we really hear about on boards and forums and stuff has to deal with how do you handle query parameters in your REST API? Is it considered cacheable or not cacheable? Like, does it affect the state of the resource or not? There's no standard querying mechanisms of how to represent or query for information. So the way we handle it is the query parameters are truly, we feel, as directives to the server on how to handle certain things, and we use query parameters as a syntax that will then in turn trigger certain query operations on our backend. So, but there's no custom API or syntax that's standardized at all. There's no effort even that I've seen that standardizes something like that. Core data? Open data? Yeah. Not that I'm aware of. It doesn't mean it doesn't exist. I just haven't seen it yet. So maybe they have a solution for that. I'm not sure, though. Okay, so, yeah.
If there are additional actions other than the CRUD, basic create, read, update, and delete, how do you define that?
That's a really good question. So if there are actions other than create, read, update, delete, how do you handle them with a REST API? And the way we handle it, it's a really good question because it does arise in certain scenarios. We actually simulate a resource-based approach for certain behaviors or actions that don't map directly to CRUD. A really good example is that because we're an identity service, you can log in users against our system. So you actually send in, credentials over SSL to us, and we will authenticate the end user for your application. You're not really creating or reading or updating or anything in the traditional sense. But what we did is we actually modeled that as an authentication attempt. Right? This goes back to the beginning where everything in REST should be a noun. And so really an authentication attempt is a behavior. It's an action being taken against the system. It doesn't necessarily translate directly to CRUD that you would see for a directory or an account, but it's a behavior being taken, and we modeled that as a noun. And so we called that an authentication attempt. And so when you authenticate a user or our system, you're actually posting to the authentication attempts endpoint, and it creates a new resource on the server, and then it just returns you, a link to the account that was successfully authenticated. And so we have used some techniques to simulate noun-based approaches to behaviors. And it will be saved to the system, and it's only accessible to certain people depending on querying reports who have secure access to that data. It wasn't like that when we first created it, though. After it became a resource, we realized it could be utilized for a lot of other things, and that actually drove our API to be a little more resource-based, and our API was better because of it. So if you can do those kind of things, I think it'll simplify how you represent those things to end users, and it'll kind of illuminate certain things in your API where there might have been holes or gaps that you could fill in. So, all right, we're going to take a look at some code. Unfortunately, we don't have a whole lot of time, so we won't be able to do step by step. But I'll show you basically the finished product of what this simple demo app looks like. You can all go to GitHub, our Stormpath GitHub area, and check out or clone the to-dos Jersey repository. And what it is, it's a very simple to-do application. Whether or not I clean the garage or picked up something from the store, and you can create and add to-dos, and you can delete them. Let's take a look at and see how that looks from a code perspective. My question is can I fit it on the screen? Can you guys? It's probably a little hard to see in the back. So one of the first things about Jersey is, this is a Palm project. We're using the latest stable version of Jersey 1.4, or excuse me, 1.14. And so all I've done, because this is a web-based project using a servlet container, it's not a standalone server using the Grizzly servlet engine, for example. But we're using the latest stable version, and these are the only two dependencies that are necessary for the project. So you can, they're available in Maven Central, they're easy to access, and we're using SLF4j as the logging API. There's nothing really complex about it. So once these two dependencies are in place, the first thing you want to do is set up, actually let me close this project, web.xml, and in this case we're just using a servlet mapping. And so we've got Jersey's servlet container servlet, and we're telling it to scan a set of packages that we specify that contain all of our JAX-RS annotations. Or excuse me, they contain classes that are themselves annotated with JAX-RS annotations. And so in this case, we've got two packages. We've got a generic controller package, which is where all of our REST controllers exist. And we've got an infrastructural package that, it's called .jersey. in the package hierarchy that contains some meta kind of infrastructural components that Jersey needs to make things work. Yes?
Jersey provide some kind of application. That's where on that application class you have to specify all the resources that you define.
Yes.
Do you recommend that versus this packages approach?
So the question is Jersey allows you to specify an application class, and inside that application class you can specify all the REST resources that you want to support. Do you recommend that over the package scanning technique? I have no recommendation. It's whatever you guys prefer. We at Stormpath like using the package approach because everything's just picked up automatically. We tend to prefer the lower friction techniques, even if it might expose something that's not 100% finished. We kind of resolve those issues in user acceptance testing, make sure that stuff that shouldn't be exposed is not. We tend to automate things where we can. So we like the package approach, but I don't have a particular recommendation. So, and also because we're focusing on JSON here, we've specified an init param to this servlet saying that we really want to utilize POJO mapping for objects that are transmitted to and from the server. And this is really necessary if you're using JSON. If you're using XML and JAX-B, I don't think this is required, but it's definitely required if you're using Jackson for JSON. So turn on this init param. And in here, we've got we're just mapping all requests to the to-do servlet. I could specify /v1, for example, but in the simple demo, I didn't. So basically, this particular web app services only REST requests and nothing else. So that's it. That's the only thing that you need in order to get the stuff up and running inside of your web app is to define the servlet, specify the JSON object, or the POJO mapping feature, and you're good to go. You'll see in the packages here, remember I told you guys I had an infrastructural package for Jersey. I'll show you what those components look like. So the first one I did is I'm customizing Jackson here. Let me expand. So Jersey provides this provider annotation that allows you to provide multiple implementations of sort of infrastructural hooks into the Jersey framework. And in this case, my provider is going to resolve a Jackson object mapper in the context for Jersey. And all I'm doing here is I'm customizing the object mapper that will be used at runtime. By default, the object mapper for Jackson doesn't assume any particular time zone or timestamp format. And also, it will not indent output, or pretty print is what people like to call this. And so for this simple demo app, I wanted to see the output in the browser pretty printed, as well as there's the ISO 8601 time zone format. So I'm just telling Jackson every time it sees a date, I want you to print it out in ISO 8601 UTC formatted date. And so these are the only two customizations I've made to Jackson to adhere to the stuff that we talked about earlier in the presentation. So this provider will make sure that Jackson mechanism is used and not the default. The other infrastructural thing that I created, this is a bit nasty. You guys will definitely want to check this out on the GitHub project. But I actually wrote a blog article about this. Unfortunately, it was in the context of Spring, but the same concepts apply here, is that Jersey has an interesting mechanism to take an exception and represent or return or set the proper error header to the client. But remember, before I was showing you guys how we want error messages to be very detailed and have a lot of information. And so this exception mapper that I created is also, as you can see, annotated as a provider component. And when Jersey starts up, it says, oh, this is an exception mapper. Anytime a throwable occurs from anywhere, I'm going to hand it off to this exception mapper, and the exception mapper is going to render the response. And so what that allows us to do is, based on any exception that occurs at runtime, whether Jersey throws it or we throw it or whatever, it allows us to take this and translates it into this custom object called a REST error. This is something that I created. Again, there's a blog article on our page if you want to see how it functions. But it takes the object and it spits out a REST error object that encompasses those 5 or 6 properties that we showed you on the REST response, right? The code, the status message, the developer message, And so whenever an exception is thrown, it'll catch it, and then it just places the status code based on the error, sets the media type to JSON, and it translates it to a map object so Jackson can handle it easily. I'll actually show you an example of what this looks like in a second. Like we'll actually fire up the server so you can see what the errors look like. But this applies for all throwables. And so there's a lot more infrastructural stuff here on how it resolves errors at runtime. One of the things that might be interesting to you guys if you use this, by the way, everything here, including the infrastructural components, is all Apache licensed. So you guys can go home, clone it, use it, take it, do whatever you want to do with it. Apache is very business friendly. The way this works actually is this guy at startup will read a properties file that I defined. And the way this works is it based on the class of the exception or any part of that class or the class's hierarchy, it will return, it says the status code. You can also specify the application specific code. You can say that the message that I want to be specified is the exception message. There's any number of parameters here that allow you to customize exactly what that payload looks like in a very short, succinct kind of definition format. So here I say anytime an illegal argument exception or a validation exception comes up, I want to throw a 400. Yes?
Where is the call for Storm in its library? The authentication part. Have you gotten to that yet?
Where's the call for what?
Storm, your library.
Stormpath? So Stormpath, I'm not demonstrating Stormpath in this the demo for Jersey. Yeah. So we have our own REST SDK and stuff that is, you can drop into any Java app or Clojure or whatever. This is plain vanilla, just a Jersey app, and you're writing it from scratch for the first time. This error mapping technique, though, is custom to what we've done in the past based on our work. And again, it's open source, so you guys can use it. The reason why we do this is because we found in practice that the Jersey exception mechanism, they have this notion of I think it's called a web application exception, and it takes in the HTTP error code that should be set as a server response. We found that to be too tightly coupled to the concept of the web. So for example, if you're using Hibernate, and Hibernate throws in, an object not found exception, right? That has nothing to do with the web. But using this technique, I can actually enter in that exception here and translate it to a valuable error message payload that will be sent back from the REST API. So the REST API has no knowledge of tier-specific exceptions. With the Jersey approach, you actually have to catch those and translate them into a Jersey-specific exception or subclass. And we found that to be too tightly coupled as a technique or as an approach. This way allows us to support any exception regardless of the tier that it comes from, runtime or not. Exactly. Exactly. So you can actually pull in the error from the message exception. Like that's what this underscore is, the special token that says the message property of the JSON payload, use it as the exception one. But other things for like authentication exceptions, we won't do that. We'll actually override that, as you can see here, and specify our own manual one. And although this doesn't work in my code sample that I have here, the one that we use will actually do a translation based on locale. So it'll be like a token that gets translated to a language-specific error message. So that's all I want to cover from the infrastructural stuff. Again, you guys can look at it. You can use the code. This is very, very useful in production apps. And it's nice because you can get a full list of all the problems or errors that might occur in your app, and you can react to them accordingly. And then, of course, down here is the catch-all. If it bubbles up in the chain and we hit the root throwable, just return a 500 server error. Yes?
Will you be going to how, does this example show how HATEOAS is distributed Hypermedia is implemented?
Does the example show how HATEOAS is implemented? It does to a certain degree. So for example, like, we've got a to-do. So let me cover the segmentation actually on how this app is structured, and then we can kind of dig into some of that stuff. So it's kind of hard to see. I wonder if I can zoom in on this part. Maybe not. Nope. Anyway, at the base there's a to-dos application, or to-dos base package, and under that there's controller. We diverge a little bit from the typical Jersey approach, where Jersey uses the word resource as the suffix for the class name, like to-do resource or user resource. We diverge from that paradigm. We like to think of these more as controllers, and the resources are the actual data that's transmitted back and forth. So you'll see in here, you'll see a base controller, you'll see a to-do controller, and these are the controllers that actually service the request and handle the responses. And the resources, in this case, a to-do resource, encompasses the data that's going to be sent back as a JSON payload. I should kind of note here that you'll see our resource object extends link, and this is a class that we created that extends link hash map. And the idea here is that for a given resource, it's always got a fully qualified base path, and there's always an entity in the system that represents that resource. So this is similar to how most enterprise applications are developed today. There's typically a base entity class that has an ID, and then you have a subclass, maybe to-do, which subclass is entity. Typically, these things are mapped to JPA or Hibernate-based kind of persistence strategies. These things kind of represent what you would interact with from a business service. And so we have, as you might expect, a to-do service, where you can get to-dos, you can get them by ID, you can save, you can delete. And this will, in essence, interact with your backend via DIOs or whatever technique you usually use to interact with a data store. The idea here, though, and kind of the meat of this, is that our to-do controller is sort of your bridge from the Jersey world into the rest of your business's services. So there's a to-do service that has no notion or understanding of Jersey, right? It's something that's core to your business API, but your controller is the thing that interacts with that service and will, let me scoot this over, interacts with your service, and then it will either return a collection resource, right? We had mentioned collection versus instant resources. In this case, a simple get to slash to-dos will return a collection resource. And the collection resource, as you might expect, supports the notion of limits and offsets, right? These are definitely more simplified than what is used in a typical production system, but hopefully it gives you an idea of how you can represent these things. What I did want to point out is both the collection resource class and the regular resource class, to-do resource, they both extend link. And all link does is provides that common href property, right? Because an href is common to every type of resource that we offer, whether it's a collection or an instance. And so by subclassing the link, even though it might seem a little counterintuitive, we get to support that base property and then add in those additional properties as is necessary for that particular type of resource. So going back to the to-dos controller, that's the list that shows a collection resource. Here I'm showing you a very simple version of an expand query parameter, right? Whether or not I want to expand the to-do, the user or not, or expand the to-do in its entirety. So if I want to expand these lists that are returned, each element in the collection will be fully expanded. Otherwise, it'll just be a link that's in the items list, right? Naturally, this would translate into a more complicated mechanism using a query language or a grammar that you can use to either turn on or off certain features. But this, at the very high level, shows you the kind of logic. Here's the create method. So in this case, we're doing a post to the slash to-dos link. We're saving the to-do. We're creating a resource, which, again, subclass is link, and then calls this common method in the parent, which is what Jersey uses to set the location header. Remember before we were talking about 201 responses need a location header? When you specify the created URI, it will set the location header automatically. This is the payload, and then you build a response, and then Jersey will, pass it off to Jackson, which translates it into a JSON object. So all of our controllers kind of extend from this base controller concept. There's the to-do controller. Yes? So the question is, JBoss has a REST Easy project. How does that fit into here? I could be wrong here, but in my estimation, REST Easy and Jackson, or REST Easy and Jersey and Spring REST are all kind of competing frameworks. You kind of just pick which one makes the most sense to you based on your background, based on your knowledge. There are pros and cons to both. Like there are certain things that Jackson does, or Jersey does, that are a little bit nicer than Springs, but Springs, on the other hand, can give you more power depending on certain scenarios. It's really based on your background. Like that's really the only difference.
311 annotation, so it
Yeah.
apply to both, right?
Yeah, that's true. Yeah, that's the one thing I forgot to announce. Like if you look at the class here, the package is javax.ws.rs, right? These are specification-specific annotations. So if your container, REST Easy, Spring, Jersey, supports these annotations, it shouldn't matter. So I should be able to take this code and deploy it on top of Spring, and it should just work. Here's an example of interacting with a particular instance resource. And so in this case, I'm using post to update data. Typically, updates can be done, like remember I said before, post, you can support both partial and full updates. For the demo, I just kind of hacked it out and said, if the data is applied, only then am I going to apply it to the underlying data model. But typically, we rely on a framework to automate this, to determine if data exists and if it does set the property. That allows you to set one or multiple properties depending on the payload. Here's a delete example. And I can actually, yeah, I'll show you real quick. I'm going to fire up what time I have left. Oh, man. I don't know how to, I guess I have to change the, let me see something here. Anyway, the server's running. Let me see. Does that work? Nope, that didn't work. Let me see. I don't know if you, a side note, you guys might find this interesting. How many people here have heard of HTTPie? You guys know what this is? We got one guy who does. This is pretty cool. It's basically a curl clone, but it's way easier to use, and it defaults or assumes JSON by default, and it color codes everything. It's just a lot easier to use. So as a side note, you might want to take a look. It's called HTTPie. It's based on Python, but you can install it very easily. It's essentially a curl replacement. It makes testing with REST services really, really easy. The question is, how do I get out of this? I went full screen on this thing, but I've never done that on the terminal before. Oh, Command Enter. Thank you, thank you, thank you. You can't really see it well, but I just issued a post to the to-do resource, and it created a brand new one. And kind of going back to our notion of HATEOAS, the user reference for the user that created the to-do is included in the link, included as a link property. Right, and so if I want to find out who that user is, all I have to do is literally copy and paste this URL, hit it in a browser, and now I see the user. And that kind of back and forth linking to resources works for, let me see if I can execute HTTP post, localhost, 8080 to-dos. Actually, let me do a get. So it gave me a collection resource back, right? href. Here's the items, the limit, the offset, and the items has a link to it. So if I actually copy and paste that link, and I do a HTTP get, then I actually get back the resource, and itself has a link back to the user. So all the techniques that we've talked about are covered in the source code. It's available under Apache license on GitHub. Feel free to check it out, clone it. I have my contact info here. If you guys need to get in touch with me, you can hit me on Twitter at lhazelwood. You can also email les@stormpath.com if you have any questions about how this stuff was set up, any of the code, any of the techniques involved. And of course, Stormpath is free for all developers to use. You can try it out if you're curious about it. But if you don't want to be another LinkedIn, check us out. So, thanks.